we're bringing it back to difference quotient here because we've been practicing quite a bit with difference quotient, especially with various polynomials. Today we're going to be taking those polynomials up a level and seeing some equations that aren't polynomials and how we can work with difference quotient with those as well. So just applying it to different applications. So write down the f of x equals x cubed, and please plug that into the difference quotient.
All right. Wait.
So to start with then, if I'm going to plug this into the difference quotient, that means I have to start by doing the f of a plus h. And so that means plugging a plus h in for where the x is in here. All right, so that means that for the first part, I'm going to be doing a plus h cubed. And then we have to subtract f of a, which means plugging the a in for x. So that's going to be a cubed. And that's all going to be over h. Nice and easy, right? I mean, there that is. That's it. That's the difference quotient. Except, of course, for this little word right here. Simplified. All right, so in order to now do this a plus h cubed, for most of you, I think, based on the work I'm seeing, you're going to actually be writing this out, a plus h times a plus h times a plus h. And you're actually going to multiply all that out. Now, when you do that, multiply two sets of parentheses, get that answer, and then once you have that, you can then multiply the result by the third. That works. Or you can actually have done this so many times that you remember what it's going to be. Oops. Although it would help if I remember to actually write the 3 in.
Yeah.
There we go.
Yeah.
All right.
That's what I got.
All right, so now that we're at this point, now we look for anything we can simplify, and you notice that we do have an a cubed minus an a cubed, and that h that's on the bottom. Now that we canceled out those a cubes, this h can cancel out of one of the h's in every single one of the terms that's on the top. And so we are then left with 3a squared plus 3ah plus h squared, and that is our difference quotient for f of x equals x cubed. So having done that, we can now add one more layer to that problem. So notice this is the exact same problem. All I added was this part over here. To evaluate the difference quotient at f of 4. So if I'm looking for f of 4, what am I plugging the 4 in as? Well, there's no x in our final equation we just made, right? Yep, so it becomes our a value. When we talk about f of 4 with difference quotient, it's like saying a equals 4. Now, do you need to plug that in and do all that work all over again?
No, just use the answer, right?
Yeah, you can just use that answer that we just found. So, do that.
Wait, what about...
And so we plug that 4 in for a in the expression that we just found, and then we just calculate it out. So 3 times 4 squared, remember square it first. So 4 squared is 16. 16 times 3 gives me 48. Plus 3 times 4 is 12, so that's a 12h. Plus h squared, we're done. There's nothing else you have to do at this point. It's not equal to anything, so it's not like we're solving it for h or anything. This is it. That is the difference quotient at a equals 4. So again, we're using the difference quotient, just this time for root x. So I'm going to turn this into the square root of a plus h, because I'm just plugging the a plus h in for x. That's the first one minus f of a. So that's just going to be the square root of a, and that's all over h. All right, can I simplify that?
No.
No, not really. I mean, there's ways we can manipulate it, but none of those manipulations will actually get us any more simplified. this is as simplified as we can get, so this one is done. That is your difference quotient for root x. Alright, so now that we're here, we can simplify. Alright, so in going and simplifying this, of course that square root of 4, we could definitely turn that into a 2, right? What about the square root of 4 plus h?
Why is it not plus?
The 4 in there has something added to it, and so I cannot just take the square root of this 4. And so because it's 4 plus h, and 4 plus h doesn't like factor into something that we can square root or anything like that, it's going to stay the same. So that is just going to stay a 4 plus h. And it's all over h still. There's nothing I can do to get rid of that h on the bottom. So that's done. That would be your final answer for that. So when we first just plugged this one into the difference quotient, this is what we're looking at. 2 over a plus h minus 2 over a all over h. But we got to get rid of the fraction within a fraction thing. Which means we have to subtract the fractions on the top. And of course, in order to subtract fractions, we need a common denominator. Now, some of you might be looking at this and saying, oh, all I got to do is get this plus h over here. However, we cannot do that, because the only way I can get that denominator to change is by multiplying it by something. And so, the only way we're going to get a common denominator is by multiplying the two by each other. And so this is really what we're doing in order to get that common denominator. And when we do that, that gives us 2a over a squared plus ah minus 2a plus 2h. Alright, so then we go ahead and we do the subtraction. So I'm going to be doing 2a minus the 2a here, which is going to give us, well, 0. That goes away. And then I'm also subtracting, notice, this 2h. So I now actually have a negative 2h over a squared plus ah. That negative is the one that we're commonly going to forget, and that's all over h. So now I can go ahead and divide that top fraction by h, which is going to give me negative 2h over a squared h plus a h squared, which means that, notice, I now do have h's in both the top and the bottom that I can cancel out. So I can cancel that one with this one and one of those. And so I end up with a negative 2 over a squared plus a h. And if you want to take that negative and you want to take the negative out front of the fraction as a whole, that's a good thing to do. So this one does simplify. Notice I can divide out of every term on the top and bottom a 2. And so we end up then with a final answer of 1 over 8 plus 2h. This is where most people end up starting, because it's what we've just been doing. Except in this particular problem, I started you off with that piece of information, the at f of 4. So we don't have to do all of this work with the a in there. We can go ahead and plug the 4 in for a right now. And by doing so, we end up making our lives so much easier.